Okay, number 6, it says a simple pendulum consists of a bob of mass 1.8 kilograms attached to a string 2.3 meters in length. The pendulum is held at an angle 30 degrees from the vertical by a light horizontal string attached to a wall as shown above. On the figure, draw the free body diagram. So I'm going to go ahead and draw that right on that picture here. I'm going to call this the tension force on the bob from the ceiling. I'm going to call this the tension force on the bob from the wall. I'm going to call this one, making these too long. Call this weight force on the bob from the earth. So there's the free body diagram. And then it says calculate the tension in the horizontal string. Okay, so I know that the tension in the horizontal string, tension on the bob from the wall, is going to be equal to the x component of the tension on the bob from the ceiling. I also know that the weight is going to be equal to the y component of the tension on the bob from the ceiling. Okay, so this will be tension on the bob from the wall is equal to the tension from the bob from the ceiling. The x component, that would be this side right here. That angle is 30 degrees, so it's going to be sine times sine 30 degrees. I can't really solve this one though because I have two unknowns, so I'm going to go to the other equation. I know it's a 1.8 kilogram mass, so that means I know the weight is 18 newtons. The y component, that would be equal to tension on the bob from the ceiling times, that's the adjacent side to that 30 degree angle, so that would be cosine times cosine 30 degrees. So I can solve that equation for the tension on the bob from the ceiling. So 18 divided by cosine of 30 degrees, and I get 20.8 newtons, I believe. Let me check that real quick. And then I can go ahead and solve for this one here. So tension on the bob from the wall will be equal to the 20.8 newtons times the sine of 30, which is half. So half of that would be 10.4 newtons. So the tension on the bob from the wall is 10.4 newtons. The tension along the pendulum string is 20.8 newtons at that location. And then part D says this horizontal string is going to be cut and it's going to start swinging back and forth. And we're supposed to figure out the period of oscillation. Well, if you remember, one of the very first labs we actually did a pendulum lab, and we found the relationship of t squared equals, I think it was something like 3.95 seconds squared per meter times L. Well, the length of this is 2.3 meters, so t squared is equal to 3.95 times 2.3 seconds squared. So that means we get a time for vibration, a period, to be equal to about 3 seconds.